Flow of electrons in a circuit.
Okay, then what is a current?
It is the flow of charge with respect to time.
With respect to time. Okay, charge is, as you said before, it's just a flow of electrons. So charge is just electrons. Cannot be, uh, can be proton or any other type.
Is it
Can it?
flow of free electrons or valence electrons?
Okay, is it not right? Even it is not wrong also. So let me make this simple. I'll make it very, very simple for that, first of all. Now, charge is something like which is getting attracted or which get affected by electric or magnetic field, either or both. So it is something related to electric and magnetic field both. So it is a what we'll say here. We'll write something like a small short as a. It is a charge is a matter which produce or experience or whatever we say. We can say produce or experience the effect of electric or magnetic. So we can say it is just a property of matter which can produce or experience effect, electric or magnetic effect. So actually there is no exact definition for this one. So it's just an understanding.
So we can say it's like manifestation of charge, like electricity.
Exactly. So we say there are two types of charges. One is positive, one is negative. Now, when we can say it is positive, when we can say it is negative.
When a neutral atom gains electrons, it's negative, and when it loses electrons, it's positive.
No, you said ulta.
No,
So
when it gains electron, it's negative, and when it loses electrons, it's positive.
yeah, so this is what we can a simple way. Yeah, that is right. We can say here deficiency of electron, and this is excess of electron. Remember this thing only we studied in the first day of the 10th standard.
Yeah.
Even it is saved here also somewhere. Okay. So Chandana, are you there?
Yes, sir.
Okay, super. So that means if it is overall, some are positive, some are negative. So overall, that is what a neutral charge also, which is all is equals to 0. That is sum of positive, which is equals to sum of negative. Sum of all positive, sum of all negative, they are equal. So if we add both, it will become 0. That means we can say in other terms, let's make some thing here. So in this case, electron, proton. This is positively charged. electron equals to proton. This is uncharged. Uncharged body. Then third one will be, what will be third one?
Negatively charged body where number of electrons are more than number of protons.
Yeah. So that means here plus outside, and here minus outside. So this is greater than this one. So this is your negatively charged body. Now here come next thing, that is charge of this conductor and insulator. So what are conductors?
The ones which allow electricity to flow through them in like larger quantities.
So why do they allow electricity flow freely?
Because they offer very less resistance against the current.
Less current, or that is improper. So answer is correct, but proper way to say that is it has free electrons. So metal which has free electrons, they are very good conductor. Like silver, copper, aluminum, they are the best conductor of electricity. Even our skin is also good conductor. Which is do you know any example of non-metal which is a good conductor?
No.
You have used this actually.
Graphite.
Yes. Graphite. Graphite is non-metal which is conductor. Other conductors you know already. Aluminum symbol, I think so, Ag. Then what happened? Then copper. No, silver, aluminum. I forgot aluminum. Yeah. Okay. Copper, and there are so many, etc. No need for that. So now this, what happens here? Like this free electrons, they move freely. The free electrons we need in outer shells, they are ready to move. So as they are freely moving, so they can just conduct with that. So if we give little supply, it will start conducting. It just a very little amount, little push, will start conducting.
So basically, the flow of electricity is easy in the metals which have the presence of free electrons.
Exactly. Now, if we go with the insulators, these people are like, they are like, okay, no, nobody should go, nobody should come. They do not allow any current charge to flow because they don't have any free electrons. If they have free electrons, then only they will allow to charge to flow. So here we can write this have no free electrons. So no free electrons means no charge to flow. Therefore, no flow. So example, I want one example from both of you.
Wood, rubber, plastic.
Yeah. Yes. What about Chandana? Any other example except this three? She said wood,
Oh, oh.
rubber,
Glass.
plastic,
Glass.
glass. Okay, glass.
Paper.
Even all non-metals
Yeah. Paper,
except
cardboard, glass.
this guy. He's only odd one out in non-metal.
So only graphite or any other non-metals?
Only graphite.
Okay.
Even here we can write mica, then yeah, this paraben wax, then that candle wax or whatever.
Okay.
What about air?
So like dry air is the insulator.
Then what about wet air?
So like basically it would be like water, right?
What happened? Why it got off? Okay. So for if we go with the liquid, in liquid we have like electrolytes. Like and name any electrolyte. Any electrolyte, any NaCl. NaCl is electrolyte.
H2SO.
H2SO4 is electrolyte. NaCl is electrolyte.
Yeah, brine solution.
Sodium chloride, right?
Yeah.
Okay. So all these are like this one. Next, we will see. We saw charge and how to charge this. There are the ways of charging. So method of charging. First one, by friction. Charging by friction. So charging by friction. So have you observed that like when we rub something, like when we are sitting on a plastic chair and suddenly we stand up and touch someone, we'll feel a little bit shock.
Yeah, like when we rub a comb on our hair and then it attracts paper or something. Electrostatic forces
Yeah,
generated.
yeah. Exactly. That is because of charging by friction. So it got when you were sitting on the chair, it got rubbed due to friction on the chair and something whatever you're wearing. So if you are wearing wool, it will be high friction. You're wearing some normal like cotton or some other, it will be very less. So it will be very less static force or static charge. So charging by friction means like two suitable bodies. Suppose some two bodies are rubbed together. So one will be two bodies. So one will be positive, one will be negative. Then only it will get attraction repulsion force. Where is my D and D? This stuff. So if I make a list of this one, this is glass rod and silk. This is fur or rod. Purposely, we will say here ebonite rod. Your dry hair and your, as you said, comb. Wool and amber. See, actually, we have said this are positive and negative charge. It's not exactly like that, but it is just assumed by us.
Because its work function of one of the component is less than the work function of other components, so they quickly lose electron or gain
Yeah,
electron.
exactly. It just for few fraction of seconds, not much longer time. It just fraction, just whatever second it is. But right now our topic is it is getting charged by friction. That's it. How much time? It's none of our business. We're not seeing that. We're just seeing okay, it's charging by friction. So next we will see by conduction. Charging by conduction. Now, if you see charging by conduction, conduction means what? Conducting bodies.
Yeah, when two
Suppose,
bodies are in direct contact with each other.
exactly. So if you see example like suppose, yeah, even your phone is also charging, right? Why we are saying charging? So when like this, our body comes with contact with some other one or touching with that. That is what, even like iron box, when you're ironing your shirt, what is happening? That iron box that is transferring some heat or electrons in form of heat to that shirt. So they are getting straightened and whatever work it is, whatever purpose it is, but it is just conducting heat. So this iron box is conducting heat to the shirt. So that iron box is touching.
So
That is called,
basically, so basically, the method of conduction means the transferring of electrons from one body to another body, so it gets charged.
yeah, by touching.
So
Okay.
it is from charged body to a neutral body when both of them are brought in direct contact.
Yeah, direct contact. And without, there is one more thing, that is without contact. That is
Induction.
induction. Induction, you heard the name, right? Induction cooker or induction stove.
Yeah.
There is no direct heat in contact, but still you are getting hot. Why?
It uses the opposite charge, like the charged body and a neutral body when they are brought near. The charged body induces the opposite charge on the neutral body.
Yes. And for this, we have one big chapter separately. Induction. EMI, electromagnetic induction. That we'll study in detail.
And we transfer
Right?
the light charge to the earth through earthing, right?
Yeah. Not through earthing. Not not only through earthing, but see,
Like in
if you,
most of the cases.
yeah, if you observe your induction stove, so what it does, like it is a coil present inside, it's not touching directly, there is one layer of it. So it is just providing heat in form of electrons. Okay, so whatever cooker, whatever things we are keeping on this, the things are getting heated up. Now, if you observe that this is only heating the thing inside, it's not heating the plate or vessel. So this is called induction. It got heat transferred directly to the required place, not on the metal surface or not on the surface which we are holding, not there, direct to the thing inside. Same work for microwave. Same goes for microwave. So heats are transferring like this. Microwave oven, they are not supplying any heat, burning or anything. It's just transferring heat. Are you able to understand what I'm saying?
So I have a doubt.
Yeah.
So basically, in mains or MSET, will the questions come like these based on theories or more numericals?
Mains will be numerical.
Okay. So like
So
the
for no,
formulas will come ahead in this.
yeah, yes.
Okay, okay.
So for knowing that formulas, we need to understand first base, right?
Yeah, yes, sir. I was just asking
Okay.
this from
Yeah, yeah, yeah. Doesn't matter. You can ask anything. Then we need, see, like this, we will solve for this thing. Then we'll see Coulomb's law. Then that comes with the question. Coulomb's law comes with question. So for Coulomb's law, we need to know what is charge.
Okay, okay.
Okay. So conduction. So conduction we saw it is by touching. Induction is by without touching, without contact. This is by contact. This is without contact. Now, some more thing we need to note for this conduction. Like when they are charging here, suppose, okay, okay, let's do with one question so that we can understand easy way. Suppose there is one charge body that is having Q, A, and there is one more body that is B, it is having charge Q. Now, C, which is uncharged body. So when uncharged body comes in contact with charged body, they will divide in two equal parts. So now A and C will have Q by 2, Q by 2, A and C. Now, if C comes in contact with B, then what will happen now?
So the C with no charge or Q by 2?
First, it was uncharged body, but still it is just having Q by 2. Now it is having Q by 2. So this will also do the same work. It will become half. So it's not just half means not Q by 2 here. Q by 2 plus Q by 2. It will become 3Q by 4. There was one question asked based on this one in your mains exam. That will
Isn't
see
it 3Q by 2 or?
3Q by 2. This 2 and this 2 will become 4.
Okay, it's compulsory to write the 2 down.
We have to divide. So what is
Okay.
my point here? What is, let's write one point so that we can remember. So when uncharged body brought into contact, okay, then separated, then two bodies will be having two equal charge. Then two bodies may, or let's say may not, have equal charges. Next, one more point here. Potential of two bodies will always remain same. Any question?
No, sir.
Both of you?
So like if there is a question where they didn't mention like if the charges are same or not, so we should always assume that the charge is divided equally.
No, not every time here.
Like if they
I
didn't
show.
mention anything.
Okay, keep this point as a star mark. Okay, so when we solve the question, I'll tell you important points where we have to use this condition. Keep this as a star mark.
Okay.
Okay. Just remember this, we will see that how we will use this. So let's see the properties of electric charges. Now, what will be the charge properties? Charge properties. Tell me one
First one is quantization of charge, where the charge is transferred or gained in whole numbers.
Okay. And some more.
Second,
How they attract or repel?
yeah, light charges repel, unlike charges attract.
Yeah. So let's write. Let's write. Excuse me. Excuse. Okay. So like charge or similar charge repel. Dissimilar attract. Now, can similar charge be attracted?
No.
No.
No? Are you sure? 100%? There is actually a rare case possibility. A rare. A very, very, very rare case. Like,
When one body charge is greater than the other.
yeah, greater in the sense so big, like infinitely big. So one body is infinitely big. So we have one big, very big positive charge and a very, very small, infinitely small positive charge. They get attracted due to induction. So next point we can say here, this always a charge body. As I said, as I wrote here some few numbers here. So according to that, a charge body attracts light uncharged body. Charged body attract light uncharged body. Like if you have seen one balloon getting or you can sticking on the wall, not exactly sticking, but it's just holding on the wall. Have you observed that?
Yeah.
So if you just rub balloon with your hair and just keep it near the wall, it will get stick there for few fraction or few seconds. But yes, it will be there. So that is this is the example for that. Like a charged body, that is your balloon. Uncharged body, that is your wall. So positively charged balloon will attract the wall's negative charge. So they will have electrostatic force of attraction there.
Okay.
So next we can say third one, we can say conservation of charge. Okay, what's your next class timing? Yeah, still time is there. Okay. Charge is conserved. Conservation of charge means, do you remember conservation of mass, conservation of energy, conservation of momentum?
It can't be created nor destroyed. It can only be transferred from one body to another.
Exactly, that's what. So charge cannot be created, not destroyed. So overall total charge of in the universe is constant. Okay, so we can say they are equal and opposite charges. So example, we say gamma particle is getting splitted into two equal and opposite particles. So here it is electron. These are positron. So what are positron?
Positively charged electrons.
Positively charged electrons.
Okay, yes. So other name is antiparticle of electron. This is called antiparticle electron. Don't worry, this is not for your like the simply I example extra I wrote here. It's not required. Mass will be same, but they are opposite in nature. Because both are electron only, so mass will be same 9.1 10 to the power minus 31. Mass will be same 9.1 10 to the power minus 31 kilogram. Fourth one, which is very, very important here. Charge is unaffected by motion. Charge will not be affected by motion of particle.
It is invariant.
Yeah, invariant we can say, yes. Charge at rest equals to charge in motion. Now fifth one we can say Q equals to any quantization of charge. So this was the basic of electrostatics, which we started now. Next we will see Coulomb's law tomorrow. And out till this 5 properties.
So what's the number 9.1 into 10?
10 power minus 31 kilogram. This is the mass of electron.
Okay.
Both mass will be same. Just one is positive, one is negative. That's it. Charge is different.
Okay.
Okay. Shall we stop sharing?
Yes, sir.